Ella, how tall are you? 4'11".
No.
What? They were. We measured you with that one.
I think we're supposed to here. Yeah, that was 6'5".
And my mom's
Yeah, you're on there. Yeah, you're on there.
I'm gonna be tall.
She's better than I am.
Bro, I'm hoping next year you.
Yeah, but I'm taller than you. I put out so much.
Yeah, that's what we're gonna do.
Stand up.
Our tall.
So many girls.
Give one of those to everybody. All right, ladies and gents. I'm not going to claim to say that this is going to be easy, but it's going to be a lot easier if you just close your mouths and listen for the most part. Still on sequences after yesterday's debacle, which actually went better than I thought. Will somebody close that door? Appreciate it. I'm going to do the best I can. This is foreign territory for me. So, something doesn't make sense, we'll cry me a river. We'll see if we can't make heads or tails. Still on this whole sequence things, which, I don't know, seems to be a pretty big deal. We have two different types of sequences. They are, drum roll please. Reagan will answer you. Stop with the drum roll. What types of sequences do we have? Recursive and explicit. And I don't know the best way to explain either one of them to you other than in order to do the recursive one, you have to know, you have to have the terms in front of you. The explicit one is like a formula that you can just plug a number in and get like the 25th term. With recursive, you have to know the 24th term, and then you do that to get the 25th term. So let's see if we can't make heads or tails of this. I will try to go slowly because I am learning in as much as you are, because this is just something I don't ever go through. But it does come up in the book, and it does come up in a bunch of other places. So here, ready? This is where you say, yes, let's do this. Let's do this. So write this down with this. First of all, here are the two recursive equations for geometric and for arithmetic sequences. Please note some important things to see here, Reagan. Important things to see here. If it's an arithmetic sequence, it's got a plus there. Arithmetic sequences, what do you do to get from one term to the other term? You add things or subtract them. In geometric sequences, you don't plus them, you multiply by a common thing. So that's what you see here. The other thing that is missing on this that I realized after scouring over this whole thing is this. In both of these, anytime you give a recursive equation, you have to state what the first term is. So in addition to giving this equation, you have to say, okay, the first term is this, okay, the first term is that. Okay, so the first thing for both of these down here, if I'm trying to write a recursive rule for those, the first thing I have to write down, well, the first term is -30, and the first term over here is, I know it's hard, kids. What is the first term there? 500. See, it's not that bad. Okay, so let's take a look at, let's see if something comes to light here. So if I'm writing a recursive rule for this, first thing you have to figure out, is it going to be the geometric one or is it going to be the arithmetic one? So you look at this. Okay, again, and maybe it helps, ladies and gentlemen, for you to draw the box. Remember, I told you it really helps me to do this. I might be the only one. Maybe it does you. Our first term is -30. Second term is -18. Third term is -6. What are you doing between the one and the other? Kavarik, even you can handle this. I am adding 12. Does that work for this? Yes, yes, yes. So if it's adding, which equation is it? It is the arithmetic one. So you are going to write this equation down there, which is a sub n equals a sub n minus 1 plus d. To write that equation, ladies and gentlemen, the only thing you need to know is what is the plus d. What is the common difference? The rest of this stays. For the formula, for the rule, you have this stays, and the plus d is what in this case? What did I say it was? What did Kavarik say? I'm adding 12, right? So the formula is a sub n equals a sub n minus 1 plus 12. And that, ladies and gentlemen, don't overthink it. That is the whole thing. And let me reiterate again what that formula means, Anderson. When you see a to the sub n minus 1, in your mind, all you're thinking is the term before the one you want. In other words, if I was looking for the fourth term here, let's say I didn't know what the fourth term was, even though I do because it's written there. Okay, you get the fourth term by taking the term in front of the fourth term, which is the third term, and adding 12 to it. So that's where the 6 would come from. But that's what makes it recursive, because if I asked you what the 12th term was, you can't just put 12 in there because you don't know what the 11th term is. That's what makes it recursive. You have to know the term in front of it to figure out the next term. So recursive is kind of like a little tougher to do because you have to fill out all the terms to get to it. Let's look at this one, which is the geometric one, I hope, because what do I do each time here? I multiply by 1/5, which is divide. Divide by 5 is multiplied by 1/5. So, ladies and gentlemen, I take this is a geometric one because it's multiplying, and the rule for this is a sub n equals whatever r is times a sub n minus 1. Wait, is that in parentheses? No, I didn't need to do that. Can I redo that? All right, want to rechange a little? I don't have a parenthesis there. A sub n equals r times a sub n minus 1. And again, in order to do it, this is recursive because you have to know all the previous terms to figure it out. We know that the letter r is 1/5 of a n minus 1, and that is your whole formula. You just take 1/5 times whatever the term is in front of it. Da? Da? All right. Here goes the part that gets really wacko. Are you ready for the wacko? Based on this next section here, by the way, here, I gave you the explicit rules for arithmetic and geometric sequences. This is how they look that are different. These two things, if you use these rules, you can just plug the term in and figure out the thing. You don't need to know the term before it. Let's see. Let's look and see if we can do this here. Okay, so first of all, this one. What do you see here? It's a minus 10. And even Anderson will tell you if it's a plus or minus, is it arithmetic or is it geometric? Even Anderson will tell you if it's minus or plus, it's what? Okay, so we're going to look at this one. Okay. And I'm going to try to get a formula or a rule for that. So I'm going to write that just like it is. A n equals a sub 1 plus, in parentheses, n minus 1 times the common difference. Where did that come from, Kelsey? The correct answer is it was given to me. It's the same thing that I have written there. I did not make that other way. You now just need to take the info they give you and fill in the blanks. Do I know the first term? Yes. Why? Because it says so right here. So a sub n is going to equal that 25 plus n minus 1. Do I know what the letter D is? David? Do I know the common difference? David? Do you see a plus or minus something there, David? Which is plus or minus?
Negative.
Yeah, it's times a negative 10. Sam has a question. Again, I will go slowly. What don't you get? This. It's the plus or minus thing. That's over there. just like this would be the common factor that gets done every time, this gets done to every term. It's a common difference, subtract, add. Now, Conrad would say, oh, good, we're done. No, we're not. In this case, ladies and gentlemen, you can actually simplify this. I can get rid of the parenthesis by doing what? Multiplying the n minus 1 both by -10, which I wish I would have left myself a little more room. And I don't really have a place to put it. Here, I'll do it right here. Can I do it here? A sub n equals 25. What is -10 times n? Anybody? Negative 10n, thank you. And what is -10 times -1? 10. I can put the 25 and the 10 together to get 35, and I still have the -10n. And ta-da, ladies and gentlemen, miraculously out of thin air comes that nice little formula. And again, this is called explicit because I can pick any old number I want for 10. What if I wanted the 15th term? I can just take 15, put it in for n here. The 15th term is 35 minus 10 times 15. So whatever 35 minus 150 is going to be that term, which is what? -110, -115. You see what I'm saying? I don't need to know the previous terms. I can just plug the n in and get my answer without. Whereas when you talk about the recursive ones, you have to know all the things in front. Don't worry, ladies and gentlemen. If you think it's confusing, it gets worse. Ready? Ready?
Yes.
Now this one. If you look at this here, what is this? This is a factor. And a factor, when it's multiplying or dividing, it's a... Oh, good. See, Kavarik wasn't even here yesterday and he gets that. So I'm going to write down this because that's my geometric explicit rule. A sub n equals a sub 1 times r to the n minus 1. You have all the bits and pieces there. What is my a sub 1? Everybody, thank you, 19.6. What is my common ratio? -0.5. And what term am I looking for? I don't know, but it's still this n minus 1. And that, ladies and gentlemen, is all you do. You can't simplify that. Why can I not multiply the -5 times that? Because powers have to be done first, and you can't really factor that out. So this is all you could do, and we would need a calculator for that because you're going to get some kind of awful decimals. How about that? I should almost stop there. Should I stop there? No. I refuse to stop there. Why? Well, because here, I'm ready to confuse you just a little bit more. Kelsey, are you ready to be confused just a little bit more? Now, notice we just started with a recursive and changed it to explicit. They now want us to start with explicit and change it to recursive. Okay, can I start with the easy one first? Conrad. I know. Believe you me, it's taken me 3 days to get to this point where I can kind of even make any sense to myself at all. Just so you know, my honor. Now this one's actually easy. Okay? Because if you look back, what is the first thing? We know this is a what? Geometric one, right? So what is, somebody tell me, what is our rule for geometric one? What is the little generic thing? It's wait, I'm not ready yet. A sub n equals
A sub 1 times r
n minus 1, right?
Yeah.
So in order to do this, I just need two things. What do I need? I need to know the first term, and I just need to know my common rate. Well, ladies and gentlemen, what are those two things? This is the first term, was it not? If you go back to what our thing was, this is our first term. So this becomes, oh wait. No, you gave me the wrong one. Oh yeah, okay. So no, you gave me the right one. So we know a sub 1 is -3, and we know that the r is 2. What is my recursive geometric rule? That's what I was actually looking for. Up on the top, what's it say? A sub n equals what?
R times A.
R times what? A.
Times A sub n minus 1.
Wait, is that an exponent or is it a bottom thing?
Bottom thing.
And I already know my r is, right? What is my r? 2. So look, it's already done. A sub n equals 3 times a sub n minus 1.
Yes.
Oh, right, 2. Sorry. I said that. Did I say it right, the wrong one?
Yeah.
Or did I write the wrong one and say it? Now remember though what I said. This was the part that's confusing. And don't worry, if you're not getting this, you're right there with everybody else. I said when you give a recursive formula, you also must state the first term. And the first term's right there. So you also have to, besides saying this, you have to also say the first term is -3. It's just what you have to do. So that's it. Enough of that. Here we go. Ready? Now this one. This one confuses me a little bit. And I haven't quite mastered it. However, Anderson, this is the workaround. Do you know what a workaround is? The way to get around probably thinking about it the way it's really supposed to be, but the way that works is I did this. Remember what I said? Anytime I get confused, guess what I do? I make a table. And what does this table look like? Well, the first term would be what? If I put 1 in for n, -2 times 1 is, -2 times 1 is +3, 1. If I put 2 in for n, -2 times 2 is +3, -1. If I put 3 in for that, I get -6 + 3. If I put 4 in for that, I get -8 + 3, which is, wait, -5. Now, Kavarik, because I have this, I can actually write that rule, because what is the recursive rule for the arithmetic one? What is it? A sub n equals what?
A sub n minus 1 plus A sub n minus 1
Plus d. And can you tell me what the plus d is? What am I doing every time?
Subtract.
To go from 1 to -1, to go from this to this, I subtract 2. So my d is subtracting 2. And there you go. That's all there is to it. Except you have to give the first term again, which is I can't change it, ladies and gentlemen, that's it. I suppose you might see a correlation as to where does this -2 appear in our original thing? Right there in front of me. I don't know. I'm a little rusty on this, but we're going to do some more. So I will not push you any farther than I myself can be pushed. Kavarik. Yes, Kavarik. One would think, wouldn't you? But that's not the way it works. Multiply what by 2, you get 4. Wait, where do you see a -2?
When you put the -2 by time, you put 2.
Times 2 gives me -4, but when I add 3 to it, I get -1. Now, ta-da, ladies and gentlemen, open up thy books, because we're going to walk our way through this assignment. Again, not asking you to do anything I myself, and you do want a piece of homework paper. I'm going to try to organize your thoughts so that I don't smell the burning brains in your head.
Ryan, I already got one.
What page? What is the page? It would be whatever lesson 6.7 is. It probably says down here, wait. Anderson has 350. 350. We're going to walk ourselves through this like no man has ever walked before. I probably don't even need to tell you this. I won't. I will just say, how about this? Emma Martin. Problem 1, 2, 3, or 4. Which one would you like to discuss? They're all under the same heading. Oh, why that one? It says simply tell whether it's arithmetic or geometric. Problem number 1 is which type and how do you know? It should be obvious to you right off the bat. Anderson already answered one of these. Why, Chris, is it what? Yeah. If it has pluses or minuses, ladies and gentlemen, it's got to be arithmetic. If it has multiplication in it, it has to be geometric. So, bam, we've already answered the first 4 questions without any trouble, correct? Arithmetic, arithmetic, oh yeah, yes, geometric, geometric. I hope that's correct. I do have the answer book. Maybe I'll go get it. Just to make sure I'm not leaving this right. UOBC ones, by the way, we're getting close to the end of the chapter here. This one's going to test even David's mathematical ability.
That's not very much.
I like that, David. I like your homework.
I'm not supposed to.
It would challenge even Frankie's.
What? I don't believe it.
Poof. All right, let's go with, look, we got a whole slew of them here. Exercise 5 to 10, write the first 6 terms, then graph it. We're going to skip the graphing because that's just putting points there. 5 through 10, Kelsey, pick me one of them. 6. They're just asking you to write the first 6 terms. You may or may not want to make a table. I don't care. But don't tell me you're confused and don't make a table, because that's my personal goal for you. Problem number 6. What would the first term be in problem number 6? If you can't tell me that, I'm a complete failure. Liam Bocek, what's my first term in problem number 6?
10.
How do I know? Because it says the first term is 10. Anybody unclear on that? Now, so look, I don't need this anymore. I just need to know what's going to happen to the second term. You take the first term and subtract 5. So here, 2, 3, 4, 5, 6. I'm just taking 5 away from the previous term. So this becomes 5, 0, -5, -10, -15. Happy with that? No, please, you don't have to. You don't have to clap there. Can I move ahead? Who clapped? Who was it that clapped? Anderson? Poof. Let's drop down a little farther here. Oh boy. 11, 12. Oh wait, I guess we have all of these. 11 through, let's not, well, we could do 18 too. It doesn't really matter. Problems 11 through 18. Lucy, which one of 11 through 18 would you like to see if all of us together with our collective brain power could not do? I knew you'd pick that one. Actually, I didn't know you'd pick that one. Let's see what the directions say. Write a recursive rule. So, thought process on 18. What would you do first? Franciscini, what should we do on 18 first? I'd make a table. I love making tables because it just organizes my thoughts here. So here we go. And here's the way the table looks. Look at, see, they have 1, 2, 3, 4. Usually the top of your table, boys and girls, is the x value or the a sub 1 or the number of the term. First term, second term, third term, fourth term. First term is -1. Second term is -4. Third term is -16, and the fourth term is -64. Step number 1 complete. Thoughts are organized. Second thought is this an arithmetic or a geometric? So you have to think, what do I do between terms? How do I go from here to here and from there to there and from there to there? It has to be consistent. What am I doing? Multiplying by 4. So it's a geo sequence. Now I have to go, I'm doing a recursive or a recursive. So then I go to look and figure out on my notes, what is the recursive whatever thing? I believe it is this. A sub n is r times a n minus 1. I take whatever term, the previous term, and multiply it by r. Guess what? I know my r is, my common ratio is 4, and there's my formula. But again, remember, I do need to give the first term when I list the formula. Otherwise, I don't know my starting point. What is my first term? Look at, give yourselves a hand. That was probably the hardest problem right there. Thoughts on that? Doable? All right, here we go. Next group of problems. Where are we at here? We're going to get to some that are really crazy hard. Let's not do that one. Write a recursive rule. No, we should be able to do that. All right, so here we go. Writing an explicit rule for the recursive rule. Ugh. Problems 21 through 26. Wait, did you already get one, Mayana? Which one do you think we should try, Mayana? Maya says, let's look at number 25. So, it is asking me to write the explicit rule. Wait, what just happened?
It only goes to 24.
What only goes to 24?
We all grabbed 2 sheets.
Oh, I am incredibly pleased with your grabbing big pieces of paper rather than small. How many people grab small? No, look at that. So, I am looking for the explicit rule for 25, to which you have to ask yourself, is 25 arithmetic or geometric? Arithmetic. Why? Because it's got the plus thing. So you need to write down what is the form of that rule. It's a sub n equals, I don't even remember. What is it? Kelsey, help me out. What is the explicit rule for arithmetic? It's a sub 1 plus a sub n minus 1 plus d. Is that what it is? No, it's not this, right? Is this here?
Yeah. And
Plus?
then plus, and then in parentheses, n minus 1, and then outside of parentheses.
Oh, so there's no a sub n minus 1 there. So this, ladies and gentlemen, is it. Right? So then I know what a sub 1 is, right? It tells me it's 4 plus n minus 1. And what is my common difference? 1.75. Am I done? No. You actually have to simplify that because you can do the distributive property. It's going to be a little ugly. You get what? 4 plus 1.75 n minus 1.75. And if you simplify that, wait, what did I do?
No.
What? What? This is 1.75 n, correct?
Yeah.
This is minus 1.75. I can only put these two together. which is 2.25. And you still have the 1.75n plus that. And that's what a sub n is. Is it not? And then again, remember when you give the recursive one, you have to give the first term. A sub 1 is 4. You have to state that. Otherwise, we don't know where our starting point is. Did that make any sense? It gets a little goofy. I will give you that. And then last but not least, of the last section there, this time we're starting with the recursive. Oh, no. We're starting with the explicit and going to the recursive. So help me if I have to say recursive or explicit one more time. This is where Hayden Clark says, let's give which one a whirl. All right, so here we go. I am going to cut that out and put it somewhere. Ready? Where'd it go? There she be. Okay. I am starting, which one am I starting with? This is explicit or recursive? I asked because I can't remember. I don't know which one is it? Because we're supposed to write a recursive from it, right?
Yeah.
So let's we're going to write down both of them. The explicit rule for geometric, because it's multiplication, is what? A sub n equals
A sub 1.
A sub 1 times r to the n minus 1 power. Yeah? That's the explicit. And the geometric is A sub n equals A sub 1 plus. Are you?
No, it's recursive form of geometric.
Right.
So it's A sub n equals r times.
Thank you. I was going to say something seemed a bit right. R times A sub 1 to the
Minus A sub n sub n.
yeah, because that makes sense. Because this is recursive. Because if you know whatever term you know, you just multiply it by whatever that thing is. Got it? So there's my 2. I know it gets confusing, but try to follow along. I am given it in this form. This is already this shape. So I know that my A sub 1 is this number. A sub 1 is, the first term is 81. The letter R is 2/3, because that's the thing in the parentheses. So I just need to translate that and put that in here, which is pretty simple because I just put the 2/3 in for the letter R. My new formula is A sub n equals 2/3 times whatever a to the n minus 1 is. And of course, remember, I also have to tell it this. So this is the 2 pieces you need. Confused? Thoroughly would be the correct answer. Which one? Here? Here? A sub a to the n minus 1. Again, remember what that means, ladies and gentlemen. The recursive thing just tells you if you know the term, the next term is whatever factor times that. So if I know that the third term, well, I don't know what the third term is. I'd have to do it out. You have to know the terms to do it. So you'd have to make the table. The first term is 81. You take 2/3 of 81. You get the next term. You take 2/3 of that term. You get the next one, which would be the third term. Done. Boom. I will let you try to finish up, do 1 through 30 there. You should be able to do it. Most of it didn't take that long. Ooh. Ella gave me that look like, ooh. I do think you can. This just takes a little bit of thought process. Again, I apologize for my lack of conciseness, but. Does anybody remember any of this on any of the MAPS tests?
Yeah.
Wait, who said yeah? If you have a question, ask, and we will muddle through together.
We've got graphics.
You can skip the graphing business.
So just